September 16th, section 1.2, talking about the rectangular Cartesian system. Basically looking at the X and Y coordinate system. Descartes is the one that developed this system, and his name is shown in the title as well. It can be the Cartesian system, rectangular or Cartesian system. You've seen a lot of this before with a few new ideas. One of the new ideas that you're going to see in this XY axis is going to be the quadrants. And notice how the quadrants rotate in this diagram. Starts with 1 and goes counterclockwise until you get to 4. This isn't a piece where you just look at it and say, okay, I've got it. We're going to be actually using quadrants for a long time in trig. So you're going to want to know those, and it's just a matter of starting with the first one and going counterclockwise. Also, what's new here is this plus or minus, and that only refers to where the X is positive and the Y is positive would be in the first quadrant. In the third quadrant, your X is negative and the Y is negative, so that's why you have a negative sign. When you graph lines, you also have slope-intercept form. We've seen that since algebra. Y equals mx plus b. M is the slope, b is the y-intercept. And another form of a line that you can write in is the standard form, which is ax plus by equals c. In this standard form, a, b, and c are integers. And integers mean that it's 0 plus or minus 1 plus or minus 2. It's like it's whole numbers and including the negative whole numbers. You really don't see fractions on A, B, and C. The way you would clear the fractions is to multiply by a denominator, and then it would be in this form. And one other thing about it in standard form is A is positive. For example, 2x plus 3y equals negative 2. The other part is graphing a linear equation, and there are different ways to graph. The next two examples are two different ways of graphing. A couple things up front on graphing in this class. One, you do not have to show tick marks as you show your numbers. All you need to do is show me numbers on the axes and call it good. If you ever draw a graph and don't show any numbers on it, the graph is meaningless to me. I have to see numbers for it to make sense. So, for example, if you have this question, graph negative 2x plus 3y equals 9, what I would do is find the x and y intercepts because it's in somewhat standard form, and go ahead and graph the 2 points and be done with it. So, find the x and y intercepts. X-intercept is going to be where the y is 0, y-intercept is where the x is 0, and then what you're doing is you're thinking, all right, what is my x and what is my y? So I can graph those 2 points and be done with graphing the line. If I substitute 0 in for y, you're going to see that this becomes 0, and therefore you're now solving for x. To solve for x, you're going to be taking 9 and dividing both sides by 2, so it'd be 9 over negative 2, which means that this is now negative 9 over 2 for your x value. Again, substituting in 0 here, solving for x, you divide by negative 2, and you're going to see it's negative 9 over 2. Leave it as an improper fraction in this class. Do not change it to a mixed number like negative 4.5. You're good, don't take the extra step, it's not needed. 0 in for x now means that 3y equals 9. You can divide both sides by 3, and you're going to see that that is equal to y. This is 3. You have your 2 points at this point. Plot the 2 points. I'm not making any dashes other than the negative 9 halves and 0, 3. I have these 2 points. Connect the intercepts, and you're done with graphing that line. The slope of this, the slope we're going to remember is going to be change in y's over change in x's. I'm going to substitute numbers in. This is going to be 3 minus 0, 0 minus negative 9 halves. And when you simplify, we have a fraction, we have a number divided by a fraction on the denominator, so we're going to multiply by the reciprocal. 3 goes into 9 3 times, so you're going to be left with 2/3 for the slope. All review. Let's go ahead and graph these lines, explain why they're graphed the way they are. X equals 2. X equals 2 means all points have an x that's equal to 2. Where is x equal to 2? Right there. Where are your points where x is equal to 2? Right there. 2, 1, 2, 2, 2, 5, 2, negative 5. You don't have to memorize that it's up and down. Just know that all those points have an x that's 2. Same thing for your y. Y equals negative 3. That's going to be horizontal. All the y's have negative 3. This other one, however, is going to be y equals negative 2x plus 4. This is in slope-intercept form. You can identify the y-intercept and the slope. Start with the y-intercept and click off the slope. I have to remember the slope is negative, which means it's going to actually rise to the left. So I'm going to start with 4. And then I'm going to think the slope-intercept, the slope is negative 2, which means I'm going to go down 2 over 1. Down 2 over 1, which means that that slope is going to be in the negative direction, and you showed 2 points on it, the intercept and the point 2, 0, so you showed enough in order to graph that one. A couple other comments on slopes, just since we're talking about them. The slope is positive if it rises to the right. It's negative if it rises to the left. It's undefined if it goes up and down. And it's 0 if it's horizontal. The reason why it's undefined if the line goes up and down is because it's change in y over change in x. Your change in x on that line is going to be 0. There is no change of x, which makes it undefined. The reason why this is 0 is because your change in x is a number now, but your change in y is 0, and that's why that is equal to 0. There's a reason behind it, we're not going to memorize it. Distance formula. The distance formula is going to be the square root of the change of x's squared plus change in y's squared. This distance formula is derived from the Pythagorean theorem. Why? It's because if you had 2 points, and you want to know the distance between those 2 points, look what happens. I'm going to have a right triangle that I draw in there. And with a right triangle, I can apply the Pythagorean theorem to find one side given 2 sides. Your change in x's is actually that side right there. You're taking your x's and subtracting them to get that distance. Your change in y's is going to be this side. And therefore, you can see now that if this were r, it would be change in x's squared plus change in y squared equals r squared. That's really what we're looking at here, except one step away, and all you're doing is taking the square root of both sides and you got it. So it's pretty easily seen that the distance formula is derived from the Pythagorean theorem. Some of you could follow that, and I like to show why things are the way they are. I don't want to spend a lot of time on it, but there's a reason we have things. Angles in standard position. This is going to be new for you, but you're going to be doing it all the time in here, so this is where you really want to focus on the new stuff. And when you draw an angle in standard position, you're always starting with the positive x-axis. So we're looking at the positive x-axis, which means I start with that ray, and from that ray I draw in the angle. Notice on this angle theta, I am starting with that ray and going up in the direction of counterclockwise. When I draw that angle, it's counterclockwise, and therefore it's positive angle. This is what you learned before on positive and negative angles. Positive angles is clockwise, negative angles would actually be the opposite direction, which is clockwise, and that's going to be negative. So that's where it's coming up. Let's take a look at coterminal angles. Coterminal angles are angles that have the same initial side and the same terminal side. Now, when you draw an angle, notice that you have 90 degrees at top, 180 degrees, 270, and 360 or 0 degrees. Those are benchmarks on how to figure out where to draw those angles. So if I want to draw a 120 degree angle, I'm going to start at 0 and move along past 90, but before I get to 180, and throw that terminal side somewhere in between. It doesn't have to be perfect, but it should be closer to the 90 than the 180. That will be 120 degrees. However, the question really is, what is the coterminal angle to 120 degrees? Same initial side, same terminal side, but going in the negative direction. Instead of going counterclockwise, I'm going clockwise, and I'm going to see it's going to be 180 degrees, plus it's going to be a little bit more than 180 degrees. Well, how much more? It's going to have to be the amount more such that the whole absolute value of both of those angles is equal to 360 degrees. The absolute value of your new angle plus the original angle has to be 360. So you can see what number plus 120 is equal to 360. That number is 240. However, you're in the negative direction. So the coterminal angle of 120 degrees is a negative 240 degrees. And this notation right here is going to come up in the book. They have a little e there, and that means element of, or terminates. Yeah. So that's just a fancy way of saying that theta ends in quadrant 2, which is what he's doing, quadrant 1, 2, 3, and 4. What is the terminal angle of 90 degrees? 90 degrees, terminal angle, coterminal angle is equal to a negative 270 degrees. Coterminal angle of 180, negative 180. Coterminal angle of 30 is going to be a negative 330 degrees. Coterminal angle of a negative 10 is a positive 350 degrees. You have the unit circles as a handout. Notice on the unit circles just a couple things. First of all, look at those angles between 0 and 90. You have 30 degrees, 45 degrees, 60 degrees. These are special right triangles that we've done previous to this, and that's the reason. So you have to know the special right angles so we can figure out values when we substitute them in trig functions. Use this as a bookmarker in your trig book, and then you don't have to worry about finding pages. I'd like to do a couple problems in the book looking at question number 66 and 72. Number 66, page number 29, says that you want to draw the following angle in standard position, and then you have to do a number of things to it, A, B, and C. So the first question is to draw it. I'm looking at 315 degrees. When I draw 315 degrees, I'm going to always put down the x and y axis, and I'm going to think, where does this make sense and where to draw it? Going here is 90, 180, 270, and 360. So it's going to be between the 270 and 360, and I'm going to draw that terminal angle. So this angle right here is going to end up being 315 degrees, positive direction. Now the first question is, name a point on this terminal ray, on the terminal side. I'm going to think about that because I have no points shown on this graph at all. There's an infinite number of points on that ray, but I'm going to choose the easiest one to work with to make my life easy. The simplest point that I can choose is going to be a point 1, negative 1. Why? It's 1, negative 1 because if I draw in a right triangle, I'm going to notice that the remaining angle is going to be 45 degrees. 315 plus 45 is 360, or you could think 360 minus 315 gives you that angle. Well, I have a 45-degree angle there, and it's a right triangle. It's my 45, 45, 90. I'm going to remember at this point, 45, 45, 90, oh, I remember those ratios of the numbers. It's 1, 1, radical 2. I'm going to go ahead and use that. So I know that this side is going to be 1. This side is going to be negative 1 because you're going down, and the point is just going to be 1, negative 1. That's an easy point on that ray. B. Find the distance from the origin to that point. The distance from the origin to the point is going to be this hypotenuse of the right triangle, your answer is right here, which is radical 2. Because I picked those ones, I know the hypotenuse is radical 2. If I didn't pick the ones, I could work my way around the right triangle, or you'd have to do the pyramid here. C. What is the coterminal angle to 360? Coterminal angle is, again, where the absolute value is at 360. So I already marked that in, it's 45, but I have to remember it's negative. Negative 45 degrees. 72. 72 says draw 60 degrees in standard position. And then find 2b. Find your b, which is the y coordinate of that particular triangle. Well, always, always, always draw these angles and triangles. So I'm going to go ahead and draw 60 degrees in standard position. I'm going to mark it 60 degrees. And then I'm going to put in that it has a point 2b. 2b point means this has to be a length of 2, and my b is the y value of that point, which means that's what I want to solve for. Well, guess what? It's a 30, 60, 90. I have to remember my 30, 60, 90s in order to do this. So 30, 60, 90 means that's my 30. This is my short side 2. How do I go to short side to the long side? I multiply by square root of 3. B is now going to equal 2 square roots of 3. And you're done. You draw it, you label it 30, 60, 90. It should make sense. You have to remember the right triangle ratios, which are now 1 square root of 3, 2. That concludes section 1.2. Thank you for being with us.